Okay, thanks everybody for coming. Wow, this is a packed room, and I'm kind of blown away. All of my talks are usually like in one of the tiny niche rooms because my talks are about like really esoteric stuff. And so this is a bit of a change for me. I decided to kind of like back up and talk about something really basic and fundamental, which is how do we design library interfaces. So this talk, we're going to be focusing on C++ gotchas. No, wait a minute. That's stupid. I hate those talks. We'll talk about tips and tricks. No, I don't like that either. We'll talk about useless and unnecessary template metaprogramming heroics. Woo, and those of you who know me would probably be surprised that we're not actually talking about that. Yeah. We're just going to be talking about best practices for using C++11 to design library interfaces. And a lot of this stuff is going to be pretty basic for this crowd, but I'm hopefully going to surprise some of you with some of my recommendations, and maybe we get some interesting conversation going. Okay, so here's how it's going to break down. First, we're going to be talking about functions, and we're going to be talking about classes, and then we're going to be talking about like larger scale designs, modules. We'll have to fake it up. Okay. So first, functions. When you write a function, whether C++98 or C++11, these are some things that you might want to think about when you're writing a function that's intended to be reused, which is like every function. Okay. Is it easy to call correctly? Hard to call incorrectly? Efficient to call with minimal copying and aliasing without unnecessary resource allocation? Is it easily composable with other functions? And is it usable in higher order constructs? Right. These are the kinds of things that you want to think about when you're writing reusable functions. And let's get really, really basic and talk about like what's the best way to get stuff into and out of a function. And just get more basic than this, right? And before we talk about C++11, let's go back in time and talk about C++98 and what was the way to do that back then. Okay, so this is kind of a chart that I came up with to describe like how you might want to do like parameter passing and function return in C++98. You've got input parameters and output parameters, and you've got in-out parameters. If the input parameter is small, you'd probably pass it by value, and if it's large, you'd pass it by constref. And if it's an output parameter, you'd return it by value. And if it's large, you'd probably pass it as an out parameter to the function by non-constref. And in-out parameters, also, you'd probably pass by non-constref. So kind of like best practice for C++98 function interfaces, like who would code by a rule of thumb sort of like this. Just about everybody has done this pretty much. So we want to talk about like how is this going to change in C++11? Okay. And in order to do that, I'll have to talk about move semantics a little bit, not all that much. So don't be scared. But let's break this down just a little bit more. Let's talk about input categories, and let's break it down into read-only and sync. Read-only, a read-only input parameter to a function is something that you obviously only read from. You never modify it locally in the function. You never store it anywhere or anything. You just read from it. Okay? And a sync is a value that's consumed, stored, or mutated while that function executes. Okay? So a good example of a read-only would be, say, an OStream inserter. You only ever read from, hopefully, you only ever read from stuff when you're writing an OStream inserter. And here, say you've got a task queue and you've got a task. And presumably, this function in queue is going to take a task and put it in the queue. Okay. So the task will probably be saved somewhere here. Okay. So let's look more closely at this read-only stuff. Here's my first guideline for the talk. It's OK to continue taking read-only input parameters by constref. Okay. If you've got a small one, you could pass it by value. Fine. Okay. Okay. Sync arguments. The goal is to avoid making unnecessary copies of your objects. Okay. by allowing your temporaries to be moved in. So you might think about writing in Q like this. Okay, I've got, an L value task and an R value task, okay? And if we've got this code over here, we've got a function that makes tasks and a task queue. This would call the copy and copy it in, and this would move it in. Okay. Well, this is pretty great, right? I mean, we don't pay for any unnecessary copies, and we're moving stuff in, and that's supposedly pretty cheap, so that's pretty exciting. Marshall?
Yeah, there's one important difference here in these two cases from now that we have multi-threading. In the second one, the one that takes by R value reference, the routine NQ can assume that the task that gets passed to it will never change during the run of the program and run of the routine, and this first one that takes it by const reference can't assume that.
Okay, so the question is, so in the comment, this function can probably, it's safe to assume that, there's not going to be a race on the thing passed in, and here you might have to worry about that. And I say that's not actually true, right? Because I can std move something, or I could cast an L value to an R value, right? And get aliasing behavior just as easily on an R value as you can on an L value. Yeah?
Yeah, you can do that. The assumption is that if you cast to an R value, whoever you're giving it to can treat it as though they're the only one.
You hope that. Yeah, for sure. Yeah. You're certainly saying it's okay to steal the guts of this object. Yeah. Which is necessarily a mutating operation. Okay. Yeah.
I guess my point would be that if either one of these could be, if you pass an object to either one of these that could be modified on a different thread, you're doing something wrong.
Probably. Yeah. The point being that,
you have a race condition.
Yeah. You shouldn't. Yeah. Right. So you're probably doing something wrong if you're worried about race conditions here. Okay. So this seems pretty great. It seems like programmer heaven, right? We're only paying for what we need to. So let's think about what happens if you take more than one sync argument to your function. Okay. Well, this is clearly not sufficient. Nothing's going to get moved in this case, right? So let's just permute. Okay. Well, this isn't heaven. Okay. This really sucks. We don't want to have to do this, right? Okay, so what's the correct thing to do, the simple thing to do? Anybody? Pass it by value. It's simple and it works, okay? Now, who's going to be the wise guy in the audience? You.
Well, there are two problems with this. First, you make the assumption of what will happen, how this value is going to be used into the interface, which is a bad idea.
Okay, I'm not sure I understand that point. It was said that you'd break the assumption of the interface?
The assumption about whether it's a sync or a value that you just read from into the interface. Let's imagine this is a virtual function,
Yeah.
a pure virtual function, and you don't know how it's exactly going to be implemented. Now you assume that it's going to be a sync, while the implementation might use it in a different way.
Okay, that's actually a fair point. So if this is a virtual function that is meant to be overridden by derived classes, and the derived classes may or may not be making copies, then the point is you might not actually want this to be like baked into the interface. Okay, and that's a fair point. Okay, that would be like a consideration. Yeah, go ahead, follow up.
And the second point is that this is not going to work for polymorphic objects. You're going to slice it.
Right, okay, so for polymorphic objects, you're going to slice, but Sean has given great talks about, the concept-based polymorphism and value semantics, and why you might want to consider designing your types that way. So I would highly recommend Googling Sean's talk, concept-based polymorphism. It was very illuminating. Thank you, Sean. Yeah, Kirk.
There
There you go. That's the wise guy answer that I was looking for. So you're going to get 2 moves sometimes when, if you wrote it the other way, you'd only get 1. And I say, I don't care. I really don't. And I don't think you should either. Chandler.
I say that we should change the standard so that you don't get 2 moves.
Yeah. So Chandler says change the standard so you don't get 2 moves, which is fine. I'd be okay with that too. But even without that change to the language, like seriously, I don't care. Okay. So this is my guideline. Take sync arguments by value. Unless you have some like extenuating circumstance, this is generally good advice when designing interfaces. Any other questions about this? No. Yeah.
I was just going to point out, to me, a sync is very, very clear if you can get away with the heap by using a unique pointer, and then it's perfectly clear what's going on.
So you could use a unique pointer for a sync. Personally, I don't like pointers at all, smart or dumb.
But it screams sync at you.
Yeah, it does. It screams sync. Yeah.
You have showed that when there is only one argument, we have an interface that avoids copy.
Mm-hmm.
And now we are doing always at least a move. When you have the 2 interfaces with enqueue, post reference, and eval reference, you are.
Okay. So the point was made that when you had an L value, you didn't have to make a copy, and you could just call this thing. But now if you have an L value, it's going to be copied in, right? Good, right? Because this is an enqueue function, and that's a sync argument. What you're going to be doing, presumably, you've got some queue inside this task queue object, maybe a vector of tasks. And what you're going to be doing is you're going to take that argument that you've been passed, and you're going to move it into the vector. So if you don't have this thing by value, so say this function took a const ref, you have to make a copy within the enqueue function. A copy has to happen, one way or the other. Yeah.
Would this be the same advice if task were a template parameter? Would you still pass by value if it were intended to be a sync argument?
Okay, so that's a good question. If you don't actually know that this object, that your object you're enqueuing has, is cheap to move, do you still do it? Do you still pass by value? I say yes. I want everyone to write move constructors. I want objects that are cheap to copy. And if you're using an expensive to copy type with this interface, then there are ways to get around that. You can encapsulate an expensive object by putting it on the heap and creating a wrapper and moving the wrapper in. But I encourage people to design their libraries and their classes so that types are cheap to move. Yeah.
Actually, followed by Brenda's point. If the task is an L value, you say that the goal, because finally you're going to copy this into the queue.
Yes.
So the copy has to happen. But sometimes, like if the task is embedded, you are going to do some check on the status of the task. If it's embedded, I'm just going to quit through an exception. I'm not going to copy it. So if I change the interface to this, the copy happens immediately.
Okay, so the observation was, depending on how enqueue is implemented, it may or may not make a copy of the task. And if that is the case, then you can't do this. Yeah.
So does this eliminate any data race possibilities like we were worried about before? It looks like it does.
Does it eliminate data races? Well, I'll say it certainly eliminates aliasing, right? That if you pass things in by value, you know you're the only one holding it, right? So you don't have to worry about aliasing problems. And yeah, I mean, it does simplify the implementation of enqueue if you are worried about threading issues. Yeah.
I mean, to the original point, like if the object did change while the copy was going on, you'd still have a data race problem, but that's...
that too. But that problem would happen outside of enqueue. It's not enqueue's problem. at that point. Yeah.
Don't you think that this is just kind of a workaround for a language limitation? And what we actually want is a universal reference where you can check inside NQ whether it's an R value or L value was passed.
So do I think this is a workaround for a language limitation where, like, I should be able to say, like, task L value or R value?
Inside the NQ.
And then, yeah, check inside NQ, did I get an R value or an L value? And it's really awkward to do that today with universal references. Unfortunately, that's not the language that we have. So yeah, I could imagine a different language design that would make this easier. But I don't have a problem with this personally. Yeah?
You indicated that you don't like pointers, smart or otherwise. On the other hand, you said you really need them for large objects that have to be on the heap, and you need a pointer to them.
Right. So the observation was, if, like I had said, I don't like pointers, and then I said, well, you could actually wrap expensive objects by putting them on the heap. The wrapper that you would create for that expensive object that's on the heap would present a value-like interface and have value-like semantics. How it's implemented is really beside the point. Yeah. Chandler.
I just want to say, I don't think this is a language limitation or defect or anything of the kind. When you have a sync argument, what you are saying is that the implementation of NQ needs a private copy of the value. A by value argument is precisely that.
Yes.
I cannot imagine a more natural way to represent this.
Yeah. So Chandler's point is, well, the semantics of this function was, I need a value here that I can then enqueue. And this is the way to express value in the language. And it's natural. Yeah?
Can I just give a concrete example? Let's say we have a set or a hash where, and the function is insert, which checks whether the value already exists, and if it doesn't, then it moves it into the hash, and if not, then it's ignored. So, you know, in one case it's a sync, and another case it's not. It's just a read-only. So, you know, here's an example where you don't really know whether it's a sync or not.
Yeah. I have a lot of slides to get to, and I know you guys are super interested in this, and I'm sorry, I'm cutting off the discussion. So I'm just going to move on. Okay. So take this or leave it. I think you should take it, but I'm moving on. Okay. So here's what we have so far. Input parameters, small and sync, passed by value, all others, passed by constref. And since we have cheap to move types, so I think output parameters should be returned by value. And now we have these weird like input-output parameters. We haven't really said anything about them yet. Pass them by non-constref, I mean, I guess, right? That's kind of unsatisfying, right? Because it hurts composability. And what do I mean by that? Okay, let's talk about getLine, my favorite whipping boy. This is a standard thing, right? You pass in a stream and it's an out parameter, so you pass in a reference to a std string that you're then going to fill in. And here's, it's kind of interesting. How come getLine doesn't return a line? Well, there are reasons for that. But okay, so this is how you're supposed to use getLine. You're supposed to like default construct a string so that you can pass it into getLine by non-const reference, and then you use a line. So you can't immediately use the result, and that's kind of an awkward and annoying and non-composable interface, and we'd like to do something about this. Think like, wouldn't it be great if getLine like returned a line, right? Imagine like getLine returns a line. I could just get a line and use it, right? I don't have to declare a variable, right? That's pretty nice, right? Anybody see a problem with this? Oh God, yeah.
Well, you cannot check whether it failed.
Okay, you can't check whether it failed. That's like, the brain dead reason. There's other reason. There's another reason, yeah.
Yeah, well, I read your
Oh, someone who hasn't read my blog. Yeah. You've read my blog. You've seen this talk before. What the hell? You don't count. Anybody else? Yeah. You're allocating tons of strings. Yes, exactly. So here's how it's typically used, okay? Typically, you declare a line, and then you get a whole bunch of lines, one after another, right? And okay, you read the first line, and now you're going to allocate some space for it, and then you use it. And then you read another line, and maybe that line is shorter than the first. You don't have to allocate more memory for it. You just fill in the string, right? And as this goes, you don't need to allocate any more memory or create new strings. This is way faster. This is a much more efficient interface. Well, that's pretty interesting. So this kind of led me to an interesting insight. Like, this is not an out parameter, right? It looks like an out parameter, but it's not. It's actually an in-out parameter because on the way in, we use the capacity of the string, okay? And this puts getLine in a really interesting category of algorithms, right? There are algorithms that can be more efficient if they like cache or pre-compute something, right? They are stateful algorithms. So here's how I would do this. GetLines, notice the plural here, returns a range of lines. Fetches the lines lazily on demand, okay? And this lines range object, it has a data member inside of type std_string that gets reused, right? And this thing has begin and end, and it returns iterators. And as you iterate through this thing, it's going to pull lines out of my stream, like this. I didn't have to pre-declare some default constructed string object just so I could pass it in by non-const reference, you know. This is really composable. I mean, lots of people have been talking about ranges this week. And, you know, if you went to Chandler's talk, you know, like, okay, this is a range, and I can now filter my lines, and I can transform my lines. Well, that's pretty great. This interface is a lot more powerful, and it's a lot easier to use, I think. Okay, you can read more about that on my blog. Okay, so let's get back to this idea of stateful algorithms, okay? Stateful algorithms, like they cache or pre-compute something. So do you want to write an interface where you force your users to declare state and then pass the state in every time you call the algorithm? Well, it's state. Like, we're C++ programmers, and we know how to deal with state. We encapsulate state in an object, okay? So encapsulate an algorithm state in an object that implements the algorithm. I kind of think of this as like an algorithm object. Kind of like a function object, although it doesn't necessarily have a function call operator, but it does implement some sort of an algorithm, okay? The lines range is one of them. Boost has this Boyer-Moore search object, which pre-computes some data and uses it to speed up string searching, okay? And so Boyer-Moore computes stuff and stores it internally so that as you call this algorithm repeatedly, that cache gets reused. It's very fast. Okay. So here's the new recommendation. Input and all others, you've got value by ref, return by value. Input output, use a stateful algorithm object. And if your algorithm object requires some initial state, well, naturally, you're going to pass that to that object's constructor. And that's a sync parameter. So you pass it in by value. Okay? This is, I think, the most important slide on the talk. You know, put this by your monitor. Design interfaces this way. Nobody does. I really would like it if they did. Yeah. Okay. Any questions about this?
So you're saying if you have a display output parameter, it's a stateful algorithm object. In that case, change it to be an algorithm object, or
turn it into a yeah. Put the state inside an object that implements the algorithm. Yeah. I'll repeat the question. The question was, so like if you have an input-output parameter, transform that algorithm with the input-output parameter into an object, and that input-output parameter becomes state in that object. Okay?
And you return that as well.
And you could, yes, you could, if that state is interesting after the algorithm completes, then you can return it. You can either move it out, you can copy it out, whatever you want. Okay? Question?
When do you use R-value reference?
When do you use R-value reference? Yeah. Wow. That was amazing. Yeah, thank you. So it's really interesting. You got this new language feature, and I'm telling you, like, never ever use it because you don't need it. Well, that's not actually true. You do need it in exactly 2 places. Well, okay, 2.5, right? You need it to implement move constructors. You need to implement move assignment operators. Okay? And if you need to do perfect forwarding, it's really handy for that. But I'm going to talk about like why you shouldn't use R-value references. So here's a slight variation, okay? And I know I promised no gotchas, but I lied. So this is a gotcha, and it's something that you all need to know about so that you know not to use R-value references in your code. Okay. Say you've got an enqueue function, it takes a queue and a task, and you think like, okay, I want to optimize away a move. So I have like an L value and an R value, okay? That looks okay. And now I say, I create a task queue, I create a task, and now I enqueue the task. Which overload gets called? It's a gotcha, so you should all know this. This one gets called, okay? Do you guys know why? Anybody?
Non-const L value?
Right, so this will get deduced to task ref, okay? So if you're like puzzling about why this is the case, if you're confused at all about why this is the case, stay away from R-value references, okay? You will do more damage than good because what this code is doing is it is stealing the guts from an L value. Oops, yeah.
So remove the first function and change standard move to standard forward.
So if I change this to standard forward, then it works.
Yes.
Yeah.
Perfect forwarding.
It's perfect forwarding.
Right. And then
Yes.
And he's right, you can get rid of the first function.
Right, but this looks fairly innocuous. Like if these were not templates and that was just task and that was just task, it's correct.
Yes.
But then you make those template parameters and all of a sudden your code doesn't work anymore. Oops. Yeah. It's kind of evil what the committee did there, a little bit. Okay? All right.
Are you on?
I am, yeah. Yes?
I mean, they're saying 2 different things on that slide. One is saying perfect forwarding, and one is saying R-value reference. It's not R-value reference, it's perfect forwarding.
Right, so Michael's point is,
Evilness is the overload of the...
yeah. So Michael's point is that ref actually means 2 things. Well, in a sense, in a sense that matters, ref can mean 2 things. It could either mean this is an R value, or it could mean perfect forwarding. And in order to understand the difference, you need to know about R value references, you need to know the rules for reference collapsing, and you need to understand the rules for template argument deduction. Like, that's just way too much to know in order to use R value references correctly. So don't do it. Okay? All right. Okay, now here's perfect forwarding. This is just a pattern. This is one place where it's okay to use R-value references aside from like move constructors and move assignment operators. Just memorize this pattern and use it as is, okay? And put that in your back pocket. Here's an interesting question. Like, say you have this invoke function that just forwards arguments to a function, a callable, right? What would be the return type here? Well, in C++11, it's decal type of this mess. But in C++14, you could say decal type auto, which is cool. Or you could just leave it off entirely, which is even better. So, progress. Okay. Okay, we're done with functions. Let's talk about classes. We're going to be talking about like designing a class that makes the best use of C++ in 11, and also allows your consumers, the users of your class, to use C++ 11 idiomatically with your type, okay? And for that, we've got to think about, these are some things to think about. Of course, copy, assign, and move. Range-based for, is your type sort of range-like? Think about iterators, right? Think about range-based for. Does it compose well? Can it be used anywhere? Can it be in static storage? Can I use the type in a constant expression? Okay? Is my type well behaved with the standard library, algorithms, and containers? These all inform the design of your class. Okay. Can my type be copied and assigned and efficiently passed and returned, efficiently inserted into a std vector? I have something very specific in mind when I say that, right? Talking about no except. Can it be sorted, used in a map, an unordered map? Can it be iterated over if it's a collection? Can it be streamed or used to declare global constants? Okay, so in order to talk about this stuff, we need to talk about regular types. And regular types let us reason mathematically about our code. And we care about regular types because we care about being able to reason about our code, but also because the standard library kind of assumes regularity in a lot of different places. And if we want our types to play nicely with the standard library, we should really think hard before we make our types irregular. Okay. How are they different? How have they changed in C++ 11? All right. Here's a C++ 98 regular type. You've got a default constructor and a copy constructor and a, better not throw, your destructor. Assignment, equality comparison, less than comparison, right? Otherwise, I can't put this thing in a map. And swap, so I can efficiently do that thing, right? The swappy thing. And that better not throw either. Okay. In addition, you've got to satisfy these semantic requirements, which is basically like you copy an object, they better compare equal, right? And if I make a copy, those copies had better be independent. I should be able to change one without changing the other. This is what it means to be a regular type. Did I get that right, Sean? Okay. Actually, I got this from Alex. Yeah. Okay. That's actually, here's the URL, Fundamentals of Generic Programming. It's online. Yeah. Okay, so in C++ 11, things are a little different, okay? We've got these two move operators. Regular types in C++ 11 are movable, and they are no except movable. That's pretty important. And, well, this is interesting. I just nuked swap. Why did I nuke swap? Because I have move. Yeah, and? The default swap works perfectly well for movable types. So you don't have to implement it anymore once you've implemented these two. Okay? That's pretty nice. And if you ever expect to hash these things, you'd have to specialize std hash. Chandler has a lot to say about that. So maybe you shouldn't. I don't know. Because you'll get it wrong. Okay. Yeah. Oh, I did get this from your talk. Yeah. Thanks, Sean. Yeah. See, I gave you credit. Yeah. Yeah. Okay. So here are a couple of guidelines. Make your types regular if at all possible. And make your move types operations no except if possible. And I know this is a drum that's been beaten before. Chandler.
What state of confusion could lead you to design a class where your type's move operation is impossible to make no except?
So Chandler's question is like, how in the world could you design a class that doesn't have a no except move operation? And I could think of like, okay, std pair, for instance, it doesn't know whether its types first and second have move.
That's merely a recursive argument.
It's a recursive argument. Yeah. Yeah.
You're speaking a question I want to ask tomorrow in my keynote and answer.
Oh, okay. I can skip this.
I'll wait.
Yeah. Yeah.
I just wanted to mention std list is actually annoyingly hard to implement.
So
The guarantees the standard requires to implement in a way that move is no throw.
Okay. The claim is that std list is very difficult to implement with no throw moves, and I'll add that if you open up the standard, std vector does not have no except move. And it makes me so mad. It really does. Yeah, Chandler. I did one better. I argued in person in the committee. Yeah, for this.
I'm writing this paper.
What's that?
I'm writing a paper about it.
Okay, so there's going to be a paper about like containers and no except swaps. Yeah, okay. Thank you. Okay, so you want to know whether your type is regular? Oh yeah, question.
So does that mean essentially both the move constructor and move assignment should be no throw?
Yes, the question is, should both move assign and move construct be no except? And yes, both of them. Yeah. Yeah.
While I know a lot of motivations to have a move constructor having no except, do we have any actual problem in the library where we benefit from a move assign operator?
So the question is there any place in the library where we benefit from no except move assign? And the answer is yes. The default swap.
Okay.
Marshall.
I have a more obscure one, and it relates to vector.
Oh yeah. So
when you move
insert.
Move assign a vector, you have to assign the allocator across.
Oh, okay. Yeesh. Okay, I don't think about allocators at all. Yeah. So the observation is I try to ignore them. Like moving allocators in the vector move assign, but we've already established that vector does not have a no except move assign. I don't think. Oh, yes, it does. It does. It does. Yeah.
If the allocator can be
Yeah.
assigned no except.
But the move constructor is not.
The move constructor is if the allocator is no throw move constructible because you could pass an allocator in.
I wonder if that's an addition, a recent addition. Anyway, let's take this offline. Okay. Make them no except if you can.
Yes, please.
Okay. So here's like a simple meta function, like you could test whether or not a type is regular or not. When you design a class, why not just add a static assert right after the class definition? Assert that my type is regular. You could even put it in the header if you want. Okay. There's something that's missing here. Does anybody know, aside from Sean? Equality comparison. Okay. There is no is-stood equality comparable. So here's I also said there was going to be no template metaprogramming. So this is, I'll gloss over this one. Here's how you implement it, right? Questions? No. Moving on. Okay. So let's motivate this with an example. Let's design a type, and I'm going to call it non-null unique putter. Okay. And it should be obvious what it is I want this type to do. I default construct one by allocating an object, so it can't ever be null, right? Or I bind one and assert that it's not null. I can get it. I don't have to check to see whether or not the putter is null because I know it's not null. I haven't allowed that. And now comes time to implement the move constructor because it's a unique putter and it should be movable because otherwise, what's the point? So how does that work? What does the move constructor do? All right, so let's rephrase, like the name of the class is non-null unique putter, so it should be obvious that this is the class invariant. Putter.get is not equal to null putter. All right. Here's like a move constructor where I steal the guts. Oops, I set the other putter to null putter. Is that okay?
If you have a precondition of get, the object that you're calling get on can be moved from, then this is fine.
If you have a precondition on get that
The type, the object that you're calling get on cannot be moved from, could not have been moved from previously.
okay. Okay, so the precondition on move is this has never been moved from, or if it has, someone's assigned to it or something, right? That's okay. So first of all, like that would be in violation of the class invariant, which I have already stated is this, right?
Well, it would be changing.
It's changing stuff. Okay, so we are the authors of this class. We get to decide what the class invariance is, And what are the preconditions on all of the member functions? Because it's our class, we get to say that. When choosing invariants and preconditions, there are a couple of things to think about, right? The things to think about are like what are my users going to expect from a type named non-null unique putter, okay? It's also going to be like, how hard is it to document this type? Because if the documentation is difficult to write, then the class is difficult to use.
Have you ever deleted a pointer and then used the pointer? Is that hard to document?
Have you ever deleted a pointer and then used the putter?
That's exactly
Well,
what move
sure.
operation is doing.
Sure, yeah,
It's effectively deleting the pointer.
right,
If there's a correlation there.
Sure.
Between the behaviors of both of them.
yeah, and it's an error in both cases.
Correct.
Yeah, Chandler.
The way I kind of try to explain this is that a move from object, right? You can call methods which have a precondition, and the precondition can be simply, that it is not in a move from state.
Yeah.
That's all the precondition has to say, and I think it's a valid precondition and an important one. We're actually right now working to build a really nice set of static analysis tools around C++11 and types like unique pointer, where you can actually document which methods of your interface don't have preconditions and thus are valid to call on objects in a move from state. And we can get really, really helpful like static warning messages if you ever try to use a unique pointer after you move out of it, right? And so I think it is a sensible kind of precondition to have, and I think we can even enforce it statically. So I don't think it's too hard to document.
Okay, Chandler says, that's not an unreasonable precondition. We might be able to build tools that enforce it statically. So we shouldn't get our underwear all in a wad about this. All right. That's just like your opinion, man. Yeah. Yeah.
So if kind of the goal of this type is to act a lot like its value, then you could just move from what it references to into what it points to here. So like you say, new T, standard move, value pointed to by other.
Okay, so the observation was you could like dereference the pointer and like move the value in. You'd still be allocating stuff here. So here's the point. Like you can like move from an L value, and now you have a type in your program whose invariants have been violated, as we have defined them. For a lot of people here, it's not a problem. I'm trying to say that it is. Yeah. And you don't have to believe me, okay? But I think there are good reasons for thinking that it's a problem, because it makes the invariants more difficult to state and makes the type more difficult to use.
It seems the underlying question is, what are you allowed to do with the move from type?
Yes. And so the committee actually has things to say about what you can do with a move from type. Like that the type needs to be in a valid but unspecified state.
Yeah, I think that even a vector you can call clear, and it's defined after it's moved, I think. But also assignment, I think, is always allowed, right?
You can call pushback after it. You just don't know what was before that last element.
There's a certain amount of gray areas that I'm trying to say that there are, and I think it's not clear because nobody has a crisp understanding of what's supposed to happen afterwards.
Okay. So lots of differing opinions. I'm not going to, sorry. Yeah, go for it. Go ahead.
I was just going to rephrase what he said, because you said this is library design.
This is library design. Yeah.
Isn't what you're allowed to do with move from object, just what does the user of this object expect to be able to do with the object? If it's been moved out of, they should not have an expectation that they can call get. They know they moved out of it. So it's not reasonable for them to expect get to work at that point.
Okay.
Only destroy, reassign.
Sure, you can. So here's the thing about types that have their class invariants violated, right? Yes, you don't know whether or not assign is going to work.
Because moving
Oh, sorry.
as a little bit as I am and as destroy temporarily.
So there was a long discussion in the standardization committee about like, okay, does a move from object, what are the requirements that need to be fulfilled? Like, does it have to be valid, or do you just have to say like it's destructible, right? And for a while, people thought, well, the type just has to be destructible, okay? That's not where they landed, right? Yeah. Yeah. Chandler.
So I think what would help me at least understand this is that if you go back to your invariant statement,
Yeah.
so this is actually a bit strange, right? You have two different invariants that are being stated in one line here. This is stating both that you can always call .get on this type, that is, .get has no preconditions, and that when you call it, the result is not null.
I see.
Right? Right. And once you understand that that's a dual class invariant, right? Like, I think everything else you're saying makes a lot more sense as to why this is challenging. And my only comment is like I don't think the first of those two should be there, right? Like I'm not saying, but it's still a useful example. Right?
Yeah. Okay, Chandler's point is, you know, I'm actually conflating things here because in my class invariant, I'm also saying things about the requirements on get, which is a valid point. Yeah, one last question about this.
So the invariant here isn't that the contained pointer is never null, just that get never returns a null pointer.
Oh, well, that's a really interesting question.
And then lazily
Point to a dummy object. Yeah. Okay. So,
Not during the move, because then the move would throw, right?
yeah. So yeah. Okay, you could. So what I'm saying is that the move from object must be in a valid but unspecified state. And you could imagine implementing it like, okay, we'll allocate a new object and swap, right? But then that's not very good. It's no different than a copy constructor. And well, it can't be no except, but that's not a deal breaker. So what I would say is that either non-null unique putter doesn't have a natural move constructor, or this type just doesn't make a whole lot of sense, right? And it's kind of interesting that it's something that at least I thought at first might be a meaningful thing, that when you reason about it from, at least from my viewpoint of like how move constructors and invariants interact, that the type itself just doesn't make a great deal of sense. Yeah?
So non-null unique pointer is an interesting example, but it's specific in that you can always observe get.
Mm-hmm.
It gives you this pointer. But there's lots of types that their internals act exactly like this type, only you don't get to see it. Namely, every single pimple type in existence. They all have a pointer to some other object, and they don't really ever want that pointer to be null. Unless you implement every function of that pimple object so that it can act if the pimple pointer is null. Which might be difficult depending on what the object does.
For sure.
So there's I've had the problem that I had a type, and it made total sense. And then I said, but I have an important reason like compilation barrier to make this a pimple, and then suddenly I couldn't implement move anymore.
Yeah.
And nothing changed in the purpose and the interface of the type. So how could I say, well, move just doesn't make sense, or this type doesn't make sense?
Okay, so the point is, like, this isn't the only type that would have this problem. There is this pimple idiom, right, where you take the guts of the object, you put it off on the heap as like just a compile barrier, right, to make compile times faster. And instead of like what you would have been doing, which is moving individual elements, which are it's presumably no throw, right? Now I have, like, I want to steal the guts from this other thing, right? And that's kind of this other thing which is allocated on the heap. Like, how do you implement a no-throw move constructor with pimple? And the answer is, I really don't think you can. Because, I mean, you have to allocate the pimple, right? So that's not no-throw.
You can in a few specific cases. You can if you can implement all the concept methods of that object so that they don't need the pimple. If they can just say, well, I'm in this moved from state, I know I'll just return 0.
Okay.
And
With a really
every non-constant method can just allocate that pimple object.
so if your pimple object has knowledge of the thing that's being pimpled, then you could assign like default behaviors in case the pointer is null. So yes, you could do that. Yes.
I will promise to answer this thoroughly. An hour.
Good. Excellent. So go to Sean's talk. Yeah.
Our invariant is that .get doesn't return a null pointer.
Yeah.
Can we keep this move assignment, or the move constructor, which assigns null pointer internally, and just throw on get on a move from object, and keep our invariant?
So could you change things so that get throws if the class invariant is broken?
No, if it's been moved from.
If it's been moved from. Keep the invariant. Oh, geez. So what is the invariant here? The invariant is
Get never returns a null pointer.
get never returns a null pointer. Okay, if this is your invariant, then throwing on violations of class invariants is just a really bad idea. And I'll tell you why. Because when your class invariant has been broken, it means most likely that somewhere in your program there is a bug. And you are probably in an invalid state, right? You can no longer trust the state of your program. Maybe the heap is trashed. Maybe the stack is trashed. Maybe, I don't know, whatever. You've had a security intrusion or whatever. Throwing an exception is going to execute a tremendous amount of code in an invalid state. You don't know what's going to happen, right? If there is any violation of a precondition violation of a precondition or a class invariant, probably the best thing to do is just to fail. That's an assert. Die. That's my opinion. Okay? Oh boy, hands. I've said something really controversial apparently. Yeah.
Well, so my question would be to you, and maybe this is where you're going. Why move this thing? It's a pointer. It's not going to give you anything.
It's an ownership.
So the question is, why move it? It's a pointer. Well, unique putter is intended to be movable. Now, you could say, well, non-null unique putter doesn't make sense, but a non-null scoped putter that is immovable makes perfect sense. Okay? Yeah.
I think it's possible to give non-null in some sense. It's just the way we implement it has some problem. When I say implement, I mean when you look at the move constructor, a moved object needs to be in a valid but destructible state. And with this, if you set the internal implementation to null, it becomes an invalid state.
Yes.
So that means we cannot reuse null to represent the state of a non-null unique putter. Which means if you really want to implement this, you can just add a Boolean field to say whether this pointer is in a valid state.
So the point being that you can add an additional state to your object that represents the moved from state.
Yeah, and forgot about it.
Which is essentially the equivalent to setting the pointer to null. I mean, that's your Boolean, right?
Is, after being moved, you can always do get, but the thing you get does not imply any ownership. It's implementation specified.
You would have to encode that in your invariants and preconditions, that was an allowable state. Yeah. I would love to discuss this further, but I have a lot more slides, and so I'm going to move on. Sorry. Okay. All right. So here are my guidelines. The move from state should be part of the class's invariant. I think we can all agree on that. No? Okay, not Sean. Go to Sean's talk. Guideline 7, if guideline 6 doesn't make sense, the type isn't movable. And a corollary, every movable type should have a cheaper to construct valid default state. Okay. But Sean's going to say this is all wrong. All right. Some wrong. Okay. So now I just want to talk about modules and larger scale design issues and what C++11 has to say about them. So here's an example of good modules and bad modules. I'm going to hope that's not controversial. So what does C++ have to offer for enforcing, say, acyclic hierarchical physical component dependencies? Or decomposing large components into smaller ones, or achieving extensibility, or versioning? Really nothing at all. We don't have module support yet, although they say it's coming. We don't even have support for DLLs, or shared objects, right? No explicit support for versioning of interfaces and implementations. And so there's no solution for the fragile base class problem. So that kind of sucks. So you might wonder, like, what am I going to say about C++11 and modules? Not much. But there are a few things that we could say. We did get a little bit. So let's talk about library versioning when you've done, when you want to make some interface breaking changes to your library. So imagine we've got this library, and we were good citizens, so we put it in a namespace, and we've got a type and a function and a template that we intend for users to specialize. Okay, and we want to evolve it to something else. Say I want to change the layout of the foo object, right? Or I want to add a defaulted parameter, or a new overload, right? How do we deal with this when we're evolving a library? So, we might say, well, okay, let's just stuff everything into a v1 namespace and have a v2 namespace and slurp all the v2 stuff out into the outer namespace. Okay. This breaks some stuff when we do this. Well, first of all, we're breaking binary compatibility, but I'm not really going to worry too much about that. But here, for instance, if v1 has, if v2 has templates in them, you won't be able to specialize them just by opening the lib namespace. And here's what I mean by that. So say we've got this situation: lib, namespace, traits, using, slurp it all into the outer, okay? And now we've got some struct that's mine. Now I want to specialize the traits template on my type. Well, this doesn't compile, because this template doesn't actually live in this namespace. It lives in that one, okay? So the committee gave us inline namespaces, and that solves this problem, okay? So we say inline namespace v2, everything in this namespace is automatically exported into the outer one, and I could just open lib and specialize the traits. That works. Okay, that's at least one problem solved. Any questions about that? Inline namespaces? Yeah.
How does this change in the face of ADL?
Oh, how does this change in the face of ADL? I think inline namespaces are transparent to ADL.
ADL?
This is not ADL. There's no ADL going on here. This is just template specialization.
Defining mine. I'm sorry, giant traits.
Yeah. Yep.
So I can clarify the ADL case. Basically, the standard has this concept of, I'm not sure what it's called, but basically when ADL refers to an inline namespace, the standard basically says Well, go up until you reach a non-inline namespace, and then take that and all its inline namespaces,
Okay.
the inline namespace within that, and treat them all as one lookup context for ADL.
Okay, so the word for that is associated namespaces. Okay, so what will happen when you define traits here? So imagine this wasn't a template. Imagine it was a type. Okay, every type in C++ has, like, bolted onto the side a list of associated namespaces. Okay, if I have namespace A, namespace B, struct S. Since S is in B, which is in A, B and A are associated namespaces of S. Okay. That means whenever I call a function and pass it an S, and if that function call is not qualified, non-qualified, then ADL is going to happen, right? So it's going to look in namespace B and A because those namespaces are associated with S. Now the point here with inline namespaces is, so if this is a function, then this is an associated namespace and this is an associated namespace. That's as before, but also if there is another inline namespace down here, inline namespace v3, then that is also an associated namespace. Did I get that right? Okay, good. Thanks. Phew. Learned something new.
I have
Yes?
a question. When we use versioning with the inline namespace, this is great for this library.
Mm-hmm.
We have version 1 and 2, both available, and 1 is the default. But when I have another library that is using this one,
Mm-hmm.
that has not been changed,
Mm-hmm.
it's not versioned, but it's using types that are defined in this
Right. Okay.
library.
So there's definitely a migration problem for your consumers, for the users of this library. So if a user of my library writes this code, right? What they might not be aware of is that they are implicitly opening a version namespace, v1. Okay. And now if you change the library so that, oh, okay, v1 is the old badness, now it's v2, and v2 is inline and v1 is not, well, this code could break. Okay. So, I mean, it is a problem for your consumers, and I've thought of this problem, and there might be hackish fixes. You could use the preprocessor to select which namespace is inline or not, and you could tell your clients, like, hey, if you're still stuck on v1, define this, and you will get all of v1 in the inline namespace, right? Otherwise, you'll get v2. It's ugly. It's the best we've got. As far as I know. I don't know of a better solution to that problem. I hate recommending the preprocessor.
Yes, me too.
Yeah. Okay. Other questions about inline namespace? No? Okay. So guideline 8, put all interface elements in a versioning namespace from day one, right? This is not something that's easy to stick back in, right? So as soon as you write a piece of code that you expect to be reusable and you want to ship a library, put it in an inline version namespace. Okay? And whatever the current version is, make it inline, and maybe do some preprocess hackery so that users don't get caught out by this when they migrate, when you migrate out from under them. Yeah. Okay. So, one other thing with regards to like larger scale software design in C++ and C++11 is ADL and name hijacking. And this isn't a problem that's specific to C++11. I just wanted to stick this in there. I'm going to briefly describe the problem of name hijacking. Most of you, maybe some of you, already know what the problem is. So say you've got a range that's got begin and end, and you've got begin and end free functions that just return the begin and the end, right? Simple enough. And this is in a range namespace, right? So say I could say, all right, I got a range of int stars, and I could use a range-based for each on that and output every integer in the range. What could be easier, okay? Now imagine I have another namespace called tasks, and I have a task with a begin, because you might want to begin a task, okay? And maybe you write a free function that's called begin, and it takes a task-like thing, and it calls the begin member function on my task, okay? This is how I start doing my work. Call it begin. What happens over here? Well, you've got a range of task pointers. Okay. That should be okay, right? I'm going to be calling begin on this thing, which isn't a task, right? It's a range. So I should be calling begin on the range. You would think it'd pick this one, right? Because it's a range. Nope. It doesn't work that way, you know, unfortunately, because what happens, so we talked a little bit about associated namespaces. When you say range, the associated namespace of that is definitely going to be range, right? But if I say range task, this is a template parameter, and its associated namespaces get tacked on to this guy's associated namespaces. Oops. That kind of sucks, and it's a little surprising. So innocuous seeming code like this doesn't compile. In this sense, it kind of breaks modularity, which is why I've stuck it in the discussion about designing code in a modular sort of way. Yeah?
Isn't it only selecting that begin because it's a perfect forwarding function, so it should have been enabled if or something?
Right. So the point is, like, it got picked because it was a better match, because it's a perfect forwarding, right? It's a gotcha. Sorry, second gotcha. Yeah.
It's not so much a question to you, but to everyone. I'm just curious. Has anyone ever wanted namespace as a template parameter to be part of ADL? Has anyone here ever said, yeah, I needed that?
Yeah, I needed that. Yeah. I did. Okay, so the question was, has anybody ever actually wanted this behavior where the associated types of a template parameter get included in the associated types of the template? And I have actually wanted it, but for a very obscure reason that isn't true anymore in C++11. And it would make your eyes bleed or ears bleed to hear about it, so I'll spare you. So I can't think of a reason in C++11 for this. Chandler.
So I have seen some uses of this where you're essentially trying to make like wrapper types and such, and so you need to have overloads from your template arguments that participate.
Yeah.
It's kind of annoying, but it does come up. I just wanted to mention that I heard a rumor that there's this person called Richard Smith who has a solution to this, and that he might eventually like write a paper or give a talk about it. I'll try and cause that to happen.
Okay. So Chandler said two things. One thing is you might actually want the template parameter to, the associated namespaces of the template parameter to become part of the associated namespaces of the template if you're writing a wrapper class, and you want the wrapper class to behave as much like the thing being wrapped as possible, including having all of its associated namespaces. And the other point was that apparently Richard Smith, who's a Clang developer and a brilliant guy, has a solution for this, and I'm curious. Yeah. Okay. Any other questions about name hijacking? No? Okay. So what do we do about this? One solution is to put all of your types in ADL blocking namespaces and export them using, a using declaration. Okay? If the type is not in the same namespace as the function, then the function won't be found by ADL, I think. I tried this. It works. Yeah.
Which, by the way, refers back to something you said earlier when you repeated my comment about associated namespace.
Yeah.
So if I have a namespace boost, namespace property tree, and within that namespace I have a type, then boost is not an associated.
Oh, I got it wrong. Okay, so sorry about that. Good point. The correction was that, and this is why I said I think, and I got confused. I confused myself. So the associated namespaces of task is tasks ADL. It's just this one namespace. It is not this namespace. However, if this were an inline namespace, correct me if I'm wrong, if this were an inline namespace, then it changes the equation, and task would have the inline namespace, the ADL blocking namespace, and the tasks namespace.
And any other inline namespaces.
And any other inline namespaces. Yeah. Okay. Thank you. Yeah.
This is a solution, but
It
before you were able to call begin of a task without using the namespace. Now you are forced to use it.
Yeah. So the point being like, okay, now I can't ever just say begin and pass it a task and have it be found by ADL. Yes, that's true. And that's a perk. Okay. ADL is a very useful thing. It's a very useful thing in certain very limited circumstances. Okay? Most of the time, though, you don't actually want things found by argument-dependent lookup. Operators, yes. Customization points, yes. Anything else? No, not really. Which brings me to my second possible solution to this problem. Okay? Make it a function object. So here's what I'm suggesting. Stop writing free functions. The only function that you should ever write is the function call operator. Except for customization points. And Gabby, yeah, go for it. A reference to a function. What do you mean by a reference to a function? Or a reference to a function, ADL doesn't apply to a reference to a function. Oh, because it's object-like. Okay, so that's another solution, but it's kind of like this one, similar.
Yeah, I put in 98 and nobody listens.
I don't expect anybody to listen to this either, but actually this is how I write my code now, and it's extremely useful. Chandler.
It prevents you from taking the address and getting a function pointer.
So you could actually hack that. Yeah. The question was. Yeah. The question was the observation was you can't take the address of this and expect to get a function pointer, but yeah, you got to do some cute metaprogramming stuff, which I've done, and it works. Works. Yeah.
The function reference only works non-templates until we get variable templates,
right? Yeah. We have
14.
Yeah.
14.
Yeah.
Wouldn't it be easier to just make that bind to a lambda?
Okay, wouldn't it be easier to make it bind to a lambda? And I would love it if that worked. Lambdas do not have const_expr constructors. I don't know why.
Next paper, working on it.
Are you working on it to give lambdas const_expr constructors? Because I would really like that, actually. I really would. And that's a great observation. Yeah. So the begin object can't ever be found by ADL. And you know, oh, by the way, yes. Okay. So variable templates. So say you boost lexical cast, right? Say you want to say lexical cast int 42. Well, in C++ 14, you could actually do that with what's called a variable template. This is an object, lexical cast, right? But its type is a template instantiation. This is new, and it's really cool. And I don't know if the authors of this paper had this use case in mind, but it's really, really awesome. It's really great. I love it. Thank you, Gabby. It's you, right? Yes. Thank you. Yeah. Very cool stuff. Okay. So not only are they not found by ADL, but if like phase 1 name lookup finds an object, then it's never going to do ADL at all. So no more name hijacking problems. And there's all this like, oh, you've got to worry about like qualifying all of your function calls if you don't want ADL. Right? You've heard that, right? People tell you, oh, qualify your function calls, you don't want ADL. Now you don't have to, right? If your functions are actually objects, then you could just call them as long as they are visible. You can just call them without qualifying them and not worry about ADL. It's pretty great. Yeah?
So one disadvantage, though, is that it requires that you define all overloads of the function in the same place, right?
Okay. So yeah, the point was you'd have to define all of your overloads in one point, in one place. And that gets back to the point I said, like, ADL is great for customization points. For extensible overload sets, yes, you need that. And so you have to continue writing free functions. But what you could do is you could write a function object that makes an unqualified call to a customization point. And then document the customization point and have everybody use the function object. And you'd use perfect forwarding for that. Okay? So also, these things are first-class objects. It's interesting to note that, like, so we have all of these standard algorithms that are higher order algorithms like for each and accumulate. They expect you to like pass in some sort of operation. But stood for each and stood accumulate, like if you ever want to pass one of those to an algorithm, you can't, because it's not a first order thing. You can't pass one of the standard algorithms. You have to instantiate it with types, which you can't really do portably. So if those were all implemented as function objects, you could just pass them around. You could std bind them. You could pass them to other higher order functions. It makes it really nice, really nice. Okay. Questions about that? You will get, like, your coworkers will scream at you. What the hell are you doing? Right? Yeah, sorry. Question all the way in the back.
Yeah, I just want to point out another advantage of that is, so you already can pass functions to higher order functions because they get reduced to a pointer. But what this allows is overload sets. You can effectively, if you do have multiple overloads, you immediately get the ability to pass it along to a higher order function.
Yeah, okay. So the point is, like, if you use like functions and passing like take the address of what essentially is a function template and have it automatically, convert to a C-style function pointer, then you lose polymorphism. With this, you don't. Yeah.
And one more advantage, depending on how you see it, because now every function has its own specific type. Every template that you pass it to will get its own specialization, which may mean code blue,
yeah,
or it may mean specialized code that is way faster, and then gets inline and completely optimized away, right?
Right. Yeah, so passing function pointers, the point is, like, that can be slow, Whereas if you pass, a type with a function call operator, that's often going to perform better at runtime, because you don't have to indirect through a function pointer. Chandler. So let me amend that. If your compiler can't tell what the function pointer is pointing to,
I have no idea where this case would actually come up. It should.
Okay.
Like, file a bug against your compiler if this actually happens, including the ones to me.
Okay. Yeah.
I guess it comes up if the compiler doesn't inline the template. If it's, say, std sort, it's pretty complicated. I kind of wouldn't want the compiler to inline std sort.
No, it doesn't have to inline. It has to specialize. Like, so all you really want it to do is you want it to specialize for a particular comparison operation, and it does do that. I remember when GCC made this change. GCC 4.5 would have the slow performance for function pointer, and I think it was 4.6 which implemented the kind of obvious transformation, which causes it to get the exact same inlining and performance
Okay.
with function
So
pointer
if you
and
pass,
with a
if you
comparison
pass a
object.
constant function pointer, then it will
It just
generate
specializes the
specialized
template on it.
That's cool.
Oh,
Didn't
that's pretty neat. Okay, so Chandler,
You don't even need the compiler to just for you. You can just detect that it's a constant function pointer and then shove it through a template argument in the library.
Yeah.
Right? So you can fix function pointers just as fast.
okay, so Chandler says the performance is not something that is a consideration, that it's going to be fast, either way. Okay.
This could be done already on C++ 89.
This can be done in C++ 98. Yeah. You can't make them const expr, but you can make them global constants. Yeah.
I just wanted to comment on what was said about passing over load sets.
Yeah.
There's been a proposal that
Hmm.
would allow lifting a name into an object.
Yeah. So there was there is a
Overload sets into function objects.
so there is a proposal to automatically lift overload sets, and it's pretty nice, and I would love that feature. We don't have it, so you could do this. Okay. Looks like we've got about 10 minutes left. Oh, here's the guidelines for name hijacking. Here's one solution, like the ADL blocking namespaces, which I don't really like, or global const expr function objects, which I think are really cool. I'm a convert. I hope you are too. Yeah.
Is there any side effects to the const expr function objects, like link time side effects?
Are there any link time side effects? None that I know of. I don't know if this is going to affect compile times or link times or anything like that.
Well, I mean, will it actually reference an object?
So will it reference the object or will it be compiled away? That's a great question for a compiler implementer, and we've got one here. So Chandler?
I'm thinking, hold on.
Well, it's typically equal to a function object itself. You don't usually take the address, right? What you take the address of is the E function in the operation.
Yeah.
But hold on. How do you define your global function objects? Go back to the code.
So like,
So that thing needs to be static if you don't want this to be different.
You can't have a static functional operator.
well, it's already static because it's const expr, which implies const, which implies static when at a global namespace.
Not in 2014.
Not in 2014?
Const expr does not imply const.
Because every const T, if you have a global variable like namespace code,
Yeah.
const T, then it immediately acquires internal linkage.
Yes,
Unless you stick external in front of it.
Right, exactly. Yeah, so Gabby's point is like a global, so a constant at namespace scope, whether declared with like const expr or const, implicitly gets internal linkage, which means it's as if you said static const. Yeah.
I don't think that was the point made. The point made is that your operator, call operator, is a non-static member function.
Yes.
You will get a this argument.
It does.
You're wasting one register.
Yes.
Possibly.
No.
The question is whether the compiler can optimize it.
No,
and
you-
it can because that's not the API.
Possibly, but I'm not.
You're unlikely to be burning a register for the this pointer. Chandler?
You are definitely burning a register to this pointer. It's an external function. You can't change the signature of it. Okay? Second off, there are a lot of ABIs where the calling convention for a non-static member function is absolutely terrible. This function will perform orders of magnitude worse on 32-bit Windows.
Yeah.
Really?
Yes.
So for on
Wow.
this particular point, we fixed this back in the 90s for GCC when STL came in. Everybody has to use less than function objects, and effectively in 97, 98, it was miserable because you're getting function object to less than of 8, for example. Instead of having 2 arguments, you get 3 arguments, including reduce the pressure. And GCC actually fixed this with having a special internal node called MC object. And for that, we report that.
The ABI still requires you to pass at this point.
So what happened is that's false.
This sounds like a hallway discussion.
Yeah. So apparently there's some disagreement between the GCC devs and the Clang devs about whether this performs well or not.
I guarantee you it doesn't perform well on 32-bit Windows.
Okay.
I like
If it's in a header.
terrible there.
So if you're on 32-bit Windows, and dear God, yeah. So it's something to worry about, seriously. Like, it's a valid concern. Okay, question.
So obviously this lexical cast definition will be in the header.
Yes.
And since it has internal linkage because it's declared context expert, doesn't that mean that anything that references it from another inline function in the header is going to have ODR violations because it's referring to something, it's referring to different objects?
Yeah, so the point was you risk ODR violations doing this. And for those not like, speaking the official lingo, ODR is the one definition rule, which means that if there is a function that takes the address of this guy, right, and does something with it, different translation units will see different addresses for this guy, okay? And if you're using that information, then you're in trouble, okay? There are ways around that. I have never found it to be a problem in practice. So it's not something that I actually lose sleep over.
You could implement the address of operator.
Don't. Chandler.
So it also requires your linker to merge the hard way every single version of this in every single translation unit. It doesn't get to do, it has to do identical code folding because they make them differently. This will cause your .o files to be seriously bloated and your linker to either be very slow when it runs or your executables to be really bloated.
Okay. The point is that this could actually have implications on compile times and object file sizes.
Code bloat, yeah.
Code bloat. That's possible. I haven't done that testing. Yeah.
So just put a static keyword there. This gets better.
So if I put static here, but I mean that's
You can't make the
you can't make this static.
Well, you can do it. You define it as static, and then you have a minimal forwarding operator, call operator, and that just gets in line.
So now to call a function, you have to say blah blah dot call.
Yeah.
Oh no. Yeah, Gabby.
Why not just write functions?
Where's the fun in that?
Gabby, get off my cloud. So the question was, why don't you just write functions? Yeah.
I think he has shown that there are a lot of problems.
There are a lot of advantages and some disadvantages. So, pros and cons. Okay. Yeah.
Would any of the disadvantages that we've just talked about still remain if you only did this inside of like a CPP file in a unnamed namespace?
So would you still have these problems if you only did it in one translation unit? And the idea is that you'd kind of like these functions to be reusable and in headers, which is where most people put their function, at least their forward declarations. Yeah. Okay. Yeah. Question all the way back.
First off, I agree that this is useful, and I don't think that it's a simple just use functions. I think that the games are valid, and this is a pattern that comes up. It's not like this is entirely new. And the second thing is, I'm not convinced that the ODR issue is as big a non-issue as it seems. Only because I think that if you take earlier on, you had like a case where you were perfect forwarding a function object.
Yeah.
And I think technically there, you can get ODR issues because you are taking the function by reference, in which case you can have multiple different references there. I'm not entirely sure of the wording of how ODR applies in that situation. So if at any point you're doing some kind of forwarding of those objects, you're going to hit ODR issues.
Okay, so 2 points that that Matt mentioned. It's a valuable technique in his opinion. Thank you. And the other thing is ODR is a real issue. And I agree ODR is a real issue. I don't know how that would actually manifest at runtime, and I don't think it would. So if you call, well, okay, you take. So you can instantiate you can instantiate a function template twice in two different translation units. In two different translation units, they'll have two different names.
Because they're implied static.
No, I'm not talking about the function object itself. I'm talking about some other function template that say you are passing this global constant object to. Okay, right? It is going to have the address of this function in one translation unit, and in another translation unit it's going to have the address of a different object, which doesn't actually matter because the object is empty, and it's going to have the exact same semantics, whichever one you choose.
I think the point,
All right.
the point that you're missing is you're calling it from, like, if you add one level of indirection and you're doing this from another function that is, defined as a template or something along those lines, the way that is written is one. I guess we're gonna have to talk offline about this, but
yeah.
I do actually believe it is ODR, and I understand what you're saying there, but I'm pretty convinced that this is actually ODR.
I think this is ODR. I think this is nitpicky, and the conversation is like angels on a pinhead. How many can we fit? Like 3. Okay, there we go. So really quick, I'm done. Like, if you are inspired, right? Here's a list of libraries that you could go hack on and make beautiful with C++ 11. The happy faces. Oh, this is like where they exist today and where they don't exist at all as far as I know. These are all libraries that either need to be written or need to be ported to C++ 11 and proposed to the standard. This is just my personal wish list. No, we don't. The point was we have an I/O library, and I disagree. We don't. Yeah.
I disagree. I get bug reports all the time.
Close won't fix. Yeah.
They won't stop the bug reports.
And here's where you can go for more information, and that's it. Okay. I'm all done. If you have any questions?
We'd like an I/O library. It's okay if it has this bug. We just want one.
All right. Well, thanks for coming, guys.